thought that it stopped, then wondered if it happened or not. You don't have to fear to explain it, look here. We will attempt to make it clear.
You may have noticed when looking at a clock, the first second appears to linger as if time itself has stood still. This is called chronostasis, popularly known as the stopped clock illusion. Has time really slowed down, or is this a perceptual phenomena?
There are multiple theories to explain this, and involve either the concept of event shift or rate increase. These are demonstrated in the following animations. During saccadic eye movements, one would expect a blurred image between one destination and another. However, this blur isn't comprehended by our brain. What our visual system does is suppress image formation, known as saccadic suppression. This empty space in our visual perception is then replaced with the very next thing we see, officially known as antedating. This leads to images being perceived earlier in time.
The second concept of rate increase involves a subjective prolongation of time. Saccades cause physiological arousal, which is known to prolong subjective time perception. Basically, we become like Spider-Man. So which theory is right? Experimental evidence appears to point to event shift. In one experiment, subjects were given an auditory and visual stimulus in quick succession. After a saccade, they were then asked to determine which stimuli occurred first. Using the rate increase concept, we would expect both stimuli to be perceived in correct order. That is, auditory followed by visual stimuli, as physiological arousal would prolong subjective time perception for both auditory and visual stimuli. Think of Spider-Man. Everything around him appears to move slower, be it auditory or visual. However, subjects judged both stimuli to be simultaneous following a saccade. This implied that the visual stimuli perceived was brought forward in time, favoring the event shift theory. Other theories based on these concepts include intentional binding and neuronal modification by middle and middle supratemporal neurons, which are too complex for even Spider-Man to understand.
Back to the prevailing theory, what is the underlying physiology of saccadic suppression? It is an active process that decreases the responsiveness of visual cells, especially in the magnocellular division, which is most sensitive to motion. The specific location is unclear, but is thought to start in the lateral geniculate nuclei.
What is the clinical relevance of the chronostasis illusion? Saccade suppression can become disrupted by conditions that affect visual processing in the primary visual cortex. Internuclear ophthalmoplegia is one example where this occurs. Patients experience blur during a saccade, sometimes leading to nausea and disorientation.
We hope it made sense without being intense. Chronostasis will be right here waiting for you.